Hello everyone. Today we are going to discuss about the design of power screw. So in that we will see the terminology of power screw, that various terms related with the power screw. So first let us see what is power screw. So power screw is a mechanical device which is used for converting rotary motion into linear motion, and it is also used to transmit the power. The power screw is also called as translation screw. There are many applications of power screw. It is used to lift the load. So basically you might have seen the screw jacks. It is used in the screw jacks. It is also used in machine tool operations, as we have seen the lead screw of lathe where we used to engage it during the threading operation. It is also used to hold or to clamp the workpiece in case of you might have seen the bench voice, which is used to hold the to hold the workpiece. It is also used in universal testing machine for the loading of specimen in the tensile testing. There are three essential parts of the power screw, that is the screw, nut and the body which holds the screw and nut. There are many advantages of power screw. First one, it is having the large load carrying capacity. Second one, the overall dimensions of power screw are very small, so it is having a compact construction. Third one is it is having a simple design. The manufacturing of power screw is easy. It means it doesn't require any specialized machinery. The square threads can be turned on the lathe, and trapezoidal threads can be manufactured on the thread milling machine. So the manufacturing is easy, design is simple. It also provides the large mechanical advantage. It means that we can lift the load of near about 15 kilonewton by applying the small effort near about 400 newton. So it is having a large mechanical advantage. The precise and accurate motions means it is used in machine tool operations, as we have seen that in the lathe machines and various machine tool operations, to provide the feed, depth of cut. We do use the power screws or the screws for the transmission of motion also. So it provides the precise and accurate motion. It also provides the smooth and noiseless operation. Also, it is having very low cost because due to the simple design, easy manufacturing, the cost is low. One more thing is it offers the self-locking properties, as we have seen that the power screws are used in the screw jack also, and they are having the ability to provide the self-locking property. So we can design in such a manner that the screw can be self-locking, so that it will hold the load when you will lift the load by using the screw jack. uh, it will not move in the reverse direction. The screw will not move in the reverse direction by itself, so that is called as self-locking property. So many applications, sorry, so many advantages as the power screw is offering, but few disadvantages are also there. First one is the poor efficiency. It offers the efficiency less than 40% basically. uh, and one more thing is high friction. Now we will discuss about the different thread profiles, that is forms of threads. First one is the square threads. Here you can see that uh, the profile of the or the pattern of the thread, it looks like a square, so it is called as a square thread. Second one is the trapezoidal threads. The form of thread or the profile of thread, it looks like a trapezoid which is having an included angle of 30 degree, so it is called as a trapezoidal thread. One more thread, it is similar to trapezoidal thread, is called as ACME thread. Only the matter of angle. In case of trapezoidal thread, The included angle is 30 degree. In case of ACME thread, it is 29 degree. Both are offering same advantages and disadvantages. If you compare the trapezoidal and ACME thread, both are having same advantages and disadvantages. Only the difference of angle is there. Fourth category is the buttress thread. So one side of buttress thread is having a profile like a square thread. Here you can see that. And the second side of that same thread, it provides the profile like a or it seems like a trapezoidal thread. So it offers the combination of square and trapezoidal threads. So you will get the advantages of both square and trapezoidal threads. So let us discuss about the various advantages and disadvantages of square, trapezoidal and buttress threads. So first advantage of square thread is having, as compared to trapezoidal, ACME and buttress thread, the square threads are having more efficiency. Second one is, as we can see that the thread profile, when there will be a load on square thread, it will act in this manner, because basically threads are used to lift the load or to transfer the force. So the load will act in case of square threads, as I have shown here. The load will act in this manner, so that again the thread profile will offer the reaction. It will be exactly in the opposite direction of the load. So here the offered load and reaction both are coaxial, we can say that. But in case of trapezoidal threads, here you can see that the thread profile is having the angle of near about 15 degree with the vertical line. If you draw a vertical line over here, let me draw the vertical line. So this particular angle is 30 degree. So due to this inclined profile, when the load will act in this manner, suppose this is the load W, there will be a normal reaction offered by the plane in this, as the normal reaction will be perpendicular to plane. So it will be like this, okay, Rn. So you can see that there will be one more component of load which will act exactly in the perpendicular to the axis of power. So this particular vertical component can be called as a radial pressure or bursting pressure. So in case of both trapezoidal threads, ACME threads, the radial pressure or bursting pressure will exist, so which increases the wear and tear of the thread. But in case of square thread, due to this vertical, as the both load and normal reaction both are coaxial, the bursting pressure will not exist. So the wear of square threads will be less comparatively trapezoidal and ACME threads, because the thread profile. So bursting pressure will not exist, or it will not observed by the square threads. So this is the advantages of square threads. Due to the bursting pressure or the radial pressure, the wear will be more. It will be in case of trapezoidal, ACME and buttress threads. Let us discuss about the disadvantages of square threads. We have seen two advantages of square threads, but there are few disadvantages also. Square threads are manufactured on single point cutting tool, by using the single point cutting tool on lathe machine. So the manufacturing time and process is complicated, so that increases the production cost of square thread as compared to trapezoidal thread. Trapezoidal threads can be manufactured by using the thread milling machine, so the time required is less, manufacturing is easy as compared to square threads. So the manufacturing is difficult and time consuming in case of square threads. One more disadvantage is there. If you see the thread profile for a square thread, you can see that this is the width or the thickness of thread at the root for the square thread, and this is the thickness of thread for trapezoidal thread and for the ACME also. The width or thickness of thread at the root is more So for trapezoidal ACMN as well as buttress threads, but for the square thread it is less. The thickness is less, so it offers less strength. So strength of square thread is less as compared to trapezoidal ACME and buttress threads. One more thing is there, we can use the split nut in case of trapezoidal thread, ACME thread, due to the angular thread profile. So that wear can be compensated by using the split nut, but in case of square thread it is quite difficult. So it is a disadvantage of square thread. Let us discuss about the advantages of trapezoidal threads. As I have said that the trapezoidal threads are manufactured by using a thread milling machine. So multi-point cutting tool can be used. It offers, means it, the time required for the manufacturing of trapezoidal threads is less as compared to square threads. So it is the advantage of trapezoidal ACME and buttress threads. So manufacturing cost is less as compared to square threads. Manufacturing cost of trapezoidal and ACME threads is less. As I have said that the thread thickness of trapezoidal threads is more as compared to square threads. So trapezoidal and ACME threads offers more strength as compared to the square threads. So it is the advantage of trapezoidal ACME thread. As I have already said that the axial wear of the trapezoidal thread due to the inclined thread profile, this offers, we can use the split kind of nut, means a two half nut can be used to compensate the wear. So we can compensate the wear in case of trapezoidal ACME threads, but we cannot use the split type of nut in case of square threads. So this is advantages, or it can be considered as advantage of trapezoidal and ACME threads. By using the split nut, we can compensate the wear. So that wear compensation is not possible in case of square threads. There are a few disadvantages of trapezoidal threads. As I have said that the square thread is having high efficiency as compared to trapezoidal and ACME threads. So it is a disadvantage for trapezoidal and ACME threads that they are having low efficiency as compared to square threads. As I have said that in case of square threads, there will not be any kind of side thrust or bursting pressure. That bursting pressure is observed in case of trapezoidal and ACME threads also. So bursting pressure, it is a radial pressure which increases the wear. So if you consider the wear of trapezoidal and ACME threads, it will be more than the square threads. So it is disadvantage of trapezoidal and ACME thread. Now we will discuss about the buttress threads. As I have said that one face of buttress thread is having a similar profile like a square thread. The angle is 90 degree, and another face is it is like a trapezoidal threads. So if you consider the efficiency of buttress thread, the buttress thread is having higher efficiency than trapezoidal threads, and also it can be manufactured on the thread milling machine. So it offers the similar kind of advantage like trapezoidal thread, that manufacturing cost and time is less as compared to square threads. Also the axial wear, due to the inclined profile, the axial wear of the thread can be compensated by using a split type of nut similar like trapezoidal and ACME threads, which cannot be used in case of square threads. But when you compare the buttress threads with square threads, buttress threads, in case of buttress thread, we can use the split kind of or split type of nut. Again, one more thing, the strength. The buttress threads are stronger than equivalent square threads or trapezoidal threads. This is because of, once again, the greater thickness of teeth at the root. One disadvantage is there also with the trapezoidal, that buttress thread, sorry, uh, due to the different kind of thread profile on the both faces. Uh, This screw can be used to transmit the power and motion only in one direction. We cannot use this buttress thread to transmit the power and motion in both the direction. But in case of trapezoidal ACM and square threads, these thread profiles can be used to transmit the motion and power in both the sides or both the directions. Okay, so here we have seen the comparison of thread forms. Next is, let us discuss about the terms, various terms related with the profile of the power screw or screw. Here you can see the square thread profile here. So the first term is the pitch. The pitch is defined as the distance measured parallel to the axis of the screw from a point on a thread to the similar point on the adjacent thread. So here you can see that this is the pitch. It is the distance from a point on a thread which is measured parallel to the axis of screw to the similar point on the adjacent thread. Next is the lead. It is defined as the distance, again measured parallel to the axis of screw, or it is the distance traveled by the screw for, or axial distance traveled by the screw for one complete rotation of screw or nut. So whatever the axial advancement will be there for one complete rotation of screw or nut, that can be called as the lead. So here you can see that when you will rotate the screw by 360 degree, it will move axially upward or downward. So that particular distance is called as lead. Next is nominal diameter. As here you can see that there are basically three terms. First is the small d. It is called as nominal or outer diameter. It is the maximum diameter of screw. It is also represented by the term DO. Second is the core diameter. It is the smallest diameter of screw. It is called as core diameter. Third one is the mean diameter. The mean diameter is the average. We can call it as it is the average of nominal and core diameter. It can be calculated by using the formula dm is equals to d plus dc by 2. The next term is helix angle. Here you can see that the thread profile is having some angle. It is having some inclination. If you will draw the horizontal line from the axis, so it is having some inclination. It is called as helix angle. So how the helix angle is calculated? If you unwound the single thread means a 360 degree thread, when it will be unwound, and when it will become straight, the distance will be equal to pi dm, means it is the circumference of the screw. And if we will plot the vertical line on this horizontal line equals to the lead, that is the distance traveled by the screw, axial distance traveled by the screw for one complete rotation. And when we will join this right angle, it will be a right angle triangle, and at that moment the angle made by this hypotenuse or inclined line, it is called as a helix angle, alpha. So how the helix angle is calculated? It is calculated by using the formula tan of alpha is equals to lead divided by pi dm, where dm is the mean diameter, lead is the axial distance traveled by the screw for one complete rotation of nut or screw. So these are the various terms which are important while designing the power screw. Okay, thank you. Two more things are there, sorry. First is the single start thread. So while designing the screw, it can be, the screw can be single start or double start or triple start also. Single start thread means when the lead will be equal to pitch. It means that for one complete rotation of nut or screw, whatever the axial distance traveled by the screw, it will be equals to pitch. When the lead L will be equals to pitch, it is called as a single start thread. And when lead L is equals to 2 into pitch, means for one complete rotation of nut or screw, the axial distance traveled by the screw will be equals to 2 into the value of pitch. It is called as a double start. So likewise, the thread can be triple start also. Okay, thank you.